Today's Daily Dose of Math starts with a situation. My friend works at a soccer field and is preparing the field for a big game. People came and painted all the lines on the field, but they forgot to put one of the penalty dots. My friend calls me and asks me, where should she paint the missing penalty dot? Trying to figure out a way to explain where to go in the field to paint the dot, I looked up regulation soccer field dimensions. And I said, okay, starting from that point X, which is at the corner of the field, walk 11 meters to the north, and then turn right and walk 34 meters to the east. Well, this did the trick, and my friend followed my directions and was able to put the penalty dot in exactly the right place. But of course, this is just an example of a situation where we would want to give directions, but to be able to give directions for two directions at once. In math, we do this often. We use what is called a coordinate plane. The coordinate plane often looks like this. You have an x-axis and a y-axis. They're labeled with their letters, and they have arrows at the right side of the x-axis and at the top of the y-axis. We also can put an O for origin at the point where the two axes meet. This is considered point 0, or it's better described as point 0, 0, because when we're at that point, we have moved 0 units in the y direction and 0 units in the x direction. For example, if I want to put a point on the graph that involves going 3 units in the y direction and then 5 units in the x direction, I start at the origin, I move up by 3 units on the y-axis, and then I move to the right by 5 units. I end up putting my dot in exactly the right place. This is how we use the coordinate plane quite often in math. But sometimes we don't need a coordinate plane that is this big. We can use a coordinate plane that looks more like this. It looks like just the top right corner of the other one, and it's useful when we don't have any negative numbers involved. For instance, what if we have some data that was collected after rolling a special dice, a 12-sided dice? We rolled it many times, and we counted how many times we got a 1, how many times we got a 2, and so on, for all of the possibilities up to 12. Maybe we're in a situation where someone has given us a coordinate plane like this one, and we're going to build a bar graph. We often build graphs using the coordinate plane as a structure to build upon. But as we start building our bar graph, it's working fine, but when we get to the point of putting the data for rolling an 8, we realize that we don't have enough room to show the data for 9, 10, 11, or 12. What should we do? I think the best thing to do is to just make the graph a little bigger, like I've done here. I drew the arrow for the x-axis further. I moved the label x a little bit further to the right, and then I was able to add extra numbers. That allowed me to add the extra data for rolls of 9, 10, 11, or 12. And my graph is finished. Don't forget to put a title on your graph. This is how we use a coordinate plane in math, in graphing. It is today's Daily Dose of Math. Please like, subscribe, and share.